Hello, in this video we're going to be finding the mean and or the standard deviation for the normal distribution. And we are going to do this by looking at one example for finding the mean, one example for finding the standard deviation, and one example for finding both. So in our first example we have A is normally distributed with a mean of 84 and a standard deviation of sigma. And we're told that the probability that A is less than 96 is 0.7352, and we're asked for the value of sigma. Okay, so although we have the mean of 84, we don't have the standard deviation, therefore we can't just use the inverse normal function on a calculator for x, we have to do it for z. So remember, z has a normal distribution with a mean of 0 and a standard deviation of 1. So I go into menu 7.3 for the inverse. I type in my area of 0.7352, my standard deviation is 1, my mean is 0, I press equals, and I get a z value of 0.6286. So using the formula from the percentage points video, x is 96, I take away the mean of 84, I divide by the standard deviation, and that gives me 0.6286. And then if I rearrange it, 96 take away 84 is 12. So sigma, standard deviation, is 12 divided by 0.6286, which is 19.1 to 3 significant figures. In our second example, it's the mean that we don't have. We're told that B is normally distributed with a mean of mu and a standard deviation of 15. And we're also told that the probability that B is greater than 125 equals 0.14. Okay, so just like in A, we are on the right-hand side of the mean, because if 14% is to the right, that means that z is positive. So again, using our formula, the x value is 125. We take away the mean, we divide by the standard deviation, which is 15, and we get a positive value of z of 1.0803. Again, that's going into the inverse normal menu 7.3, typing in an area of 0.14 with a standard deviation of 1 and a mean of 0. And then again, if we rearrange the equation, so we can times by 15 and then add mu and take away whatever 1.0803 times 15 is, and we get a mean of 108.8. For our third and final example, we know neither the mean nor the standard deviation, but we're given two facts. We're told that the probability that x is less than 51 is 15%, and the probability that x is greater than 99 is 1%. And from that, we will be able to work out the values of mu and sigma. So again, we can use the inverse normal with the z distribution. So in this case, we want an area of 0.15. So going to menu 7.3, area 0.15, standard deviation 1, mean 0, and we get a z value of negative 1.0364, and that will be equal to our x minus mu over sigma. X is 51, we don't know mu or sigma. But then we can do the same thing again with the other fact. So the probability that x is greater than 99 is 1%, 0.01. So if I go back into menu 7.3, I type in an area of 0.01, and I work out what the z value is. I need to make sure that it's a positive z value, because we're on the right hand side of the graph. So 2.3263, and that is equal to 99 minus mu over sigma. Okay, and although we don't know either mu or sigma, I hope you can see we've got a pair of simultaneous equations. If we then multiply both sides of each of our equations by sigma, we get 51 minus mu is equal to negative 1.0364 sigma, and 99 minus mu is equal to 2.3263 sigma. And as both equations have a minus mu, I can subtract one from the other. So I've done 99 take away 51 to get 48, and 2.3263 sigma take away negative 1.0364 sigma, so essentially adding them together and getting 3.3627 sigma. So then sigma will be 48 divided by 3.3627, which is 14.3 to 3 significant figures, and I can work out mu by going back and substituting my sigma into any of the equations above, and I get 65.8 to 3 significant figures. So that's how you can find the mean or the standard deviation or both.